All right. Good morning, ladies and gentlemen. Guten Morgen, or moin moin. Can I get a good morning from everybody? Good morning. Thank you. So welcome to the first plenary session on Industry Day at the 69th International Astronautical Congress. And I have to commend you for getting up early for the first plenary, but you're not going to be disappointed because Industry Day is really packed. I am Robbie Sumanto-Roy, the Corporate Vice President for Technology Strategy and Innovation at Lockheed Martin, and it is my pleasure to introduce you to Industry Day. I'm also the chair of the IAF's Industry Relations Committee, and have the pleasure of having the leadership of this committee along with two wonderful co-vice chairs, Clay Mowry and Mark Mulqueen. And so a thing I just wanted to briefly say about the introduction to Industry Day. So as you all know, that the IAF is about 3G diversity: gender, generational, and geographical. But our Industry Relations Committee has also embraced a fourth G, which is genre, which means that from an industry perspective, we are embracing the diversity of the largest systems integrators in the aerospace and defense sector, all the way down to the smallest startups. So this is one of the exciting things about our Industry Relations Committee is we're embracing this full dimension of diversity. So, without further ado, what I'd like to do is introduce you to Clay Mowry, who is a vice president at Blue Origin. He's also my co-vice chair of the Industry Relations Committee, as well as many other functions within the IAF. I just refer to him as a high-ranking IAF official. And Clay is going to kick off the first plenary, which is going to be really focused on an exciting topic of how the high-tech sector and the commercial sector has been interacting with the space industrial sector. And so without further ado, Clay, you have a wonderful panel, and I'll turn it over to you. Thank you.
Thank you. Good morning, everyone, and welcome. Moin moin, guten morgen. Welcome to our plenary session here on Industry Day. It's nice to have you here with us. We wanted to have a conversation this morning, and basically a conversation bringing in a lot of high-tech industry to talk about how the tech industry and space and satellite industry are interconnected. And so we see more and more companies now using space-based data in applications here on the ground, and really it's becoming an applications-driven world that we live in. And these things are becoming inexorably linked. And so on your phone you have navigation chips for Galileo, for GPS, for Beidou and others that are now really incorporated in all the applications you're using on the phone. We're seeing new ways of communications satellites linking in now with ground-based terrestrial networks, artificial intelligence, robotics, Earth imagery. These are all being used now into applications on personal devices that we're using every day. And so we want to have a conversation, talk a little bit about these trends and themes. I've got a great set of panelists for you here. How it's going to work, I'm going to ask each of them, I'll introduce each of them, ask them to speak for a couple of minutes, and then we'll go straight into questions and answers. I also have the ability to take your questions here on the iPad, so please join in the conversation with us, and we'll get started. So I'm going to start working from my left, your right, down the line here, and introduce my panelists. So we'll start with James Brashaw with Planet. If you don't know about Planet, they design, build, and launch the world's largest constellation of Earth imaging satellites. And James is leading their commercial team in the EMEA region here for the use of remote sensing content and analytics. His experience spans from intelligence, spatial database infrastructure, building information modeling, customer analytics, and enterprise information management. So James, please kick us off.
Thank you very much. Well, good morning, everybody. Planet. What's Planet's mission is all about imaging the world every day to make that change visible, accessible, and actionable. In terms of the constellation, we've launched over 150 satellites. They operate taking pictures and imagery every day, which is then fed through into our ground control systems and accessible to our customers. That imagery effectively is like a line scanner. So we're able to capture images of the Earth and right across the globe for all the landmass every day. That inevitably gives us a deep set of information which we can use to analyze. So we're building up every day a stack of imagery and able to monitor change. So what is Planet about? Planet's about understanding where change occurs, detecting change, providing that information so we can understand how the planet changes, how it evolves, look at trends, look at issues, start to analyze and understand what's going on. We're moving as a business from the pure imagery into actually converting pixels to data. So trying to understand what's behind the imagery, and that whole process gives our customers the ability to understand how change is affecting them. The key thing there is machine learning, so I'm really interested to hear about how AI is evolving, because we're all at this sort of early stage of evolution of moving from pure pictures into this data world. My background is from data, so I like the fact that we're actually making that, the industry's making that shift. But we've got some great examples already. We're doing a lot of work in agriculture, looking at how crops yields, looking at the whole way that works, as well as also looking at things in terms of land and urban change and being able to automate the process of converting pictures into objects so that we can actually understand. Our overall mission, our mission 2, is to basically index the world in the same way that Google did. So we want to get to the point where we make and deliver on the concept of a queryable Earth. So we're able to look at the objects, like you see in the pictures. Those are just pictures. I want to be able to look at that golf course and know what's the par 4, what's the stroke index, all those sort of things. Ultimately, we want to be able to look at the pictures and get data.
Fantastic. Well, thank you for that introduction. Our next panelist, second to my left here, is Antonio Abad-Martin with Hispasat. If you're not familiar, Hispasat's a leading satellite communications provider. They do video distribution, private network, and broadband services, both in the EMEA region and in Latin America. And Antonio is the Chief Technical and Operations Officer. He's been designing satellite networks and operations centers, buying launches on rockets for, gosh, I don't know, 20, 25 years more, maybe? More than that. And a good friend, and talk a little bit about not only satellites, but maybe some high-altitude platforms and other things that they're entering into. So, Antonio?
We'll talk about that.
Yeah.
Thank you. So, the communication satellite industry, or the SATCOM industry, has been living very well for many years from the television business. For many years, the satellite proved to be the most perfect infrastructure to transmit signals from one to many, and covering wide areas with the television signals in the most efficient way that terrestrial infrastructure could never do. We've been living on that for 30 years. It's been really a nice time. But as you're probably aware, in the last year, the change in the television consumption patterns from linear TV to on-demand TV is changing our business. And when we look at the future, what we see is that our future growth opportunity are not directly related to broadcast, television broadcast, but are more related to the connectivity of people. So I think that the satellite in the next years need to be focused in the connectivity. This connectivity business is not a one-to-many business like we used to do in the past. It's a one-to-one with many ones-to-ones. And in that sense, we need to recognize that current satellite architectures are not optimized for this new way of using the satellites. So for that reason, I think that the SATCOM industry need to open and need to start looking for what's going to be the future architecture of the communication satellite in the next years in order to optimize for this connectivity business.
Thank you, Antonio. To Antonio's left is Eric Klaus with TomTom. You may know TomTom from its navigation products. They've been doing a lot of, I think, movement from the consumer business now more into the commercial products business. Started with mapping software and products for your dashboard and cameras and GPS sports watches, but now more getting into the fleet management and side of the commercial business. So Hervé works in their Maps products unit. He's responsible for their database management in France, Benelux, and the North Africa region, and working on moving maps applications and their applications into real time. So I'm interested in hearing about that and what you're up to at TomTom.
Thank you, Clay.
Yeah.
So I'm very pleased to be here speaking today. So yeah, TomTom basically, well, you all know it has started from the consumer business. So now, of course, there is high competition from the handset, and this part of the business is declining. But TomTom is basically relying and continues its business relying on three main assets. So one is maps, because this is a common thing, and we continuously invest in maps. But we also, next to maps, provide services. So real-time services such as traffic, weather, and parking information lately. And the last component is software, so navigation software. So all those three components now are basically sold into various verticals. So the main one being automotive. So this is dragging the industry at this moment. But also, as you said, fleet management and consumer, and also enterprise. So we have a number of B2B customers which trust our products in order to conduct their business. So the interesting thing about TomTom, so we are basically not within the space industry, but we are an active user of it. So we do use our space basically in two different segments. So one being more the consumer part, which I would say is displaying pictures, there's observation pictures as a contextual information, or as a way for our customers to basically make analytics out of it. But also we use space obviously for positioning, because all of our systems rely upon the current position systems which exist. And then there is the most important piece where we basically use space is the mapping business. So map updates requires now from well, there is a strong push from the market on the freshness, real-time maps, and we are basically geared up to live that promises. So we've built up systems to deliver data within 48 hours from a change. But of course, I mean, this systems works, but we also need sources which are in sync with this. And space definitely is one of them. So we are looking at space to offer this freshness. And but not only, we also look for the resolution, because we need to see very fine details on the pictures, as well as accuracy, because we are going to move into autonomous driving, and this may require a greater deal of accuracy.
Fantastic, thank you. To my farthest left, we have Alison Lundis with Nvidia. Many of you may not be familiar with Nvidia, but they are probably the company with the biggest market cap of any of us here, doing quite well and leading in the artificial intelligence world. They do designing graphics processing units, GPUs, that are used in the gaming industry, but also a system on a chip. You tell us what that is.
Yeah.
System on a chip units for mobile computing and automotive markets, and really leading the way in artificial intelligence, which I think is a theme we can all talk to a little bit here today. So Alison is responsible for their artificial intelligence developer relations in the EMEA region. She's combining technical and theoretical computer science with a physics background and international project management. And she consults to a wide range of AI applications, including planetary defense with NASA, ESA, and the SETI Institute. So this is fantastic. Welcome. Please tell us a little bit about what you're doing.
Thank you. It's wonderful to be here. I was at ESA yesterday. We were doing another workshop. Basically, I joined Nvidia about 3.5 years ago, and not bad for a gaming company, right? Mm-hmm. I think the fact that it is a gaming company is what keeps us really, really agile, and allows the entire company to pivot and adjust with what's happening. And it really is a revolution. It's actually the third time coming, but we know just from the amount of investment now, and this is across the board, in all different fields and arenas, that artificial intelligence, AI, is making profound impact. And I've personally made it my mission to make space a vertical for Nvidia. One of the first things that I did when I joined is I helped establish something called the Frontier Development Lab, and this is because NASA was sitting up saying, okay, how do we harness AI? How do we start to take this tool, this very, very powerful tool, and put it to the extraordinary amount of data that's coming from just today's constellations of satellites. So we're lucky enough to have things like Copernicus, so this is open sourcing some of the data, but we're just at the beginning of the new space industry, combining with old space itself. And ESA, for one, are really sort of opening their arms to new space and the innovation that's coming from that. And NVIDIA is right behind that. And that's because of the actual GPU and the power of having both compute but also visualization. So what do you do after you've analyzed, this mountain of data? And this is streaming data. Earth Eye is now streaming full color video from low Earth orbit. And how do you analyze and then visualize? Because we cannot possibly comprehend. So Frontier Development Lab, one of the first things they did this year, ESA just came on board. NASA's been pretty much hosting us for 3 years now. They focused on Earth observation. And that was using data, but there was a lot of industry help. Google came on board. They were offering compute. It was our GPUs in the cloud. UNICEF also came on board to help with geotagging the data. And we had 2 teams of people, and they basically came up with disaster response solutions. They came up with something called informal settlement detection. So this is slum areas. We have no idea really around the world where these are and how you can situate them. And there's some really, really cool techniques, and you can just go online and get loads of information. But we're also sort of integrating everything, and that's blockchain technology, that's virtual reality, and simulation is a big part of the space industry as well. Being able to train and test in simulation, obviously is zero cost. So it's a fun area.
That's fantastic. So, we have Earth observation here, we have imagery, we have navigation, precision navigation and timing, we have satellite communications, and we're linking them all in with this massive computing power and the ability to make real-time decisions based on all these inputs. So it's an interesting piece. So James, why don't we start? How is this Earth observation industry or the digital industry, how is this changing and shifting? What do you see happening here?
So the Earth observation industry has been focused predominantly about capturing the pictures.
Yeah.
With the shift now to data, from pixels to data, it sort of opens up and Earth in terms of understanding how that fits in with the overall picture. So straight away things like data governance, data standards, interoperability, the actual ability to actually make the data work together becomes critical, because no longer can you operate in an isolated environment. So we're effectively moving from the area from maps into data, and so therefore standards become really, really important. So that's a key element.
Who sets those standards?
Well, there's a lot of those standards out there already for data. In terms of spatial data, there's lots of European initiatives that have been looking at how to make data interoperable. There's spatial data infrastructures. So it's not like the Earth observation industry has to create these things. They exist already today. And that's where I've come from. I've come from that background where it's about how you fit your data within that context. And Hervé's in their industry are very well aware of their data and how that works in that area. So it's moving into an area where it's all about scale, it's about size. So it suddenly becomes, we're now in an interconnected world. We're also in an interconnected industry, and I think that's the key thing I think we'll see.
So a lot of this is connecting now to our mobile devices, and we've had 3G, 4G. Now we're moving into 5G. Antonio, can you talk a little bit about 5G? How does the satellite industry play with the 5G world?
Well, as I said at the beginning, I think that there are great opportunities in the future in the satellite business if we are considering the connectivity business. Within this connectivity business, we need to realize that the satellite is not a niche anymore, like we used to be in the television business. And in the connectivity business, the only way it will work is as long as the satellite integrates with the rest of the networks. At the end, we need to realize that the user really don't care or if he is connected by satellite, by fiber, by ADSL, or whatever. The only thing is that people want connectivity everywhere, every time. And there are specific places and there are specific times where the only way to get connectivity is through non-terrestrial non-terrestrial connections. And this is where I think the space communication business needs to go. We need to open to other kind of infrastructure, like we've been talking about low Earth orbit satellite, like high altitude platforms. We need to find all kind of potential infrastructures that could allow us to go into this connectivity every time, everywhere business. And we need to realize that according to the SIA, the communication, the space communication business today is like 4% of the whole telecommunication business. So as long as we open the space communication to the connectivity business, we have a great opportunity, we have a great market that we can access by doing that. And the integration in the 5G is key to get to that.
I guess we tend to think of space as an industry, but it's really more a platform for delivering ones and zeros to users on the ground. And so it's an interesting...
Absolutely, yeah. We fully concur with that. It's a place to provide the infrastructure. It's a way to provide the infrastructure. But I think we need to open our doors and we need to consider that, as you're saying, it's not an industry itself. We are part of the telecommunication industry, and we need to make use of all the potential opportunities and all the potential technologies that can leverage this non-terrestrial infrastructure to become part of our lives and to provide connectivity to all the citizens.
There's a lot of discussion now about connected cars and self-driving cars, and how do we integrate maps and navigation and do this in real time with networks, with decision-making that we're all going to be safe when we're in these cars and we're driving. Can you talk a little bit about that and where TomTom is?
Yeah. So indeed, connected cars is something that is quite hot at this moment. So now all of the cars that are on the market are somehow connected. So connectivity is two things. It's downstream, upstream. So downstream, the user benefits from all the services which we can think of, real-time traffic, real-time parking, EV stations, availability, payment systems, what have you. But then there is also this upstream of data. So all the cars are collecting this massive amount of data, whether this is their position, wiper status, fog lights, what have you. So all those data basically are coming back to integrators like us. And we either produce new services out of this in order to further improve, but we can also make this benefit to other verticals. And indeed, in the space industry, what I see is that we are going to create new ways to consume the data, because knowing that something happens somewhere may be very meaningful in order to gain time and to know immediately where changes has happened. And with this notion, then we can trigger either satellites or information gathering and what have you, in order to get instantaneous data and awareness of a certain spot. So I think we haven't started yet to fully explore the possibilities, and I'm sure there will be tons of new use cases. But the industry will have also to evolve from what James was saying, this monolithic approach of capturing pixel in bulk towards something more agile, but also in terms of business, new business models, how to consume this new data into an agile way, so that it doesn't become an invoice too hard to swallow, basically.
Alison, gaming, space, are we going to see GPUs in space?
Yeah, so they should have been there already, but the problem is new space, the number of innovative startups and launch windows. It's a real roadblock. So we're currently waiting for our embedded GPUs, which the product name is Jetson, so Jetson's in space. And we're waiting for them to actually go up, and this would be with an organisation that is going to send TV to the world. If you've ever sort of watched the ISS ISS viewer. Basically, you can just go onto the website and watch, the world go by as ISS orbits. It'll be that kind of thing, but for the world, and there'll be TV stations. So that's just one of very many. And I think it's the innovation coming from new space, or the startups themselves, that will provide the momentum. And we don't really need to physically worry about how are we going to find the business cases, because they will just appear. Launch windows are a slight problem at the moment, but I know there's even innovation in that respect. There's in how to actually launch and to help the vast number of startups. GPUs definitely in space though, and it is, as Herv said, automotive is literally driving the entire industry. It's driving the whole of artificial intelligence.
No pun intended.
No.
It's
Well,
driving the
do you know, I
industry.
keep thinking of other ways to say it, but there's no other way to say it. It's a huge market, financially, and so it's worthwhile putting the investment in. And we're spending billions. We've developed our latest embedded, which is called Xavier. This is what you were talking about before, the SoC. It combines 6 separate processors, and so it can basically cover all of the intelligence. We're not talking anymore just onboard processing. We're talking about enabling onboard highly parallel processing and intelligence. How do you decide how much of the data you actually download, that you send downstream? Is it really worthwhile taking up that bandwidth? You need some kind of intelligence. That's just one little aspect. The other thing is intelligence in robotics on spacecraft themselves. It's really endless, and we're leaving it to new space, but it's old space, shall we say? NASA that's basically provided that platform. NASA, ESA, DLR, all of the space agencies have provided the platform, and it's just very, very exciting and very fast-paced right now.
Great. Antonio, I'm going to come back to you for a second, which is you're an operator of geostationary satellites, but there's a lot of discussion now about low Earth orbit communication satellite networks, huge networks, thousands of satellites in low orbit. And we've got some pictures here we've shown of high altitude platforms, or aerostats, these dirigibles or winged vehicles that loiter in the high atmosphere and provide communication services. So how are we transitioning from GEO to LEO to HAPS, or how do they work together?
I don't see it as a transition. I think that we are complementing different infrastructures. I think that GEO satellite will stay there forever. I mean, this is a very efficient way to communicate in specific regions where you can point into a fixed area and cover very well a fixed area. However, low Earth orbit can provide the capability of deploying a constellation, can give some very interesting feature for some very niche applications. I think that we will see some constellations in the next years, and we are working and we are contributing to the development of this new low Earth orbit constellation. For, like I say, I don't really see the low Earth orbit constellation for the general broadband services, because there's still the issue of the ground terminals that is not there. But for some niche applications, I think that these constellations will be very, very interesting. And last, as you were saying, what we're seeing lately is that through high altitude platforms, we can have very small granularity in the detection of small located markets that we can address with high altitude platforms. This will have coverages like 70 kilometer to 100 kilometer diameter. So it will cover small regions, and it has the advantage that you can deploy and then you can take it down within several month periods. So you can deploy the infrastructure. If it doesn't work, you can take it out and move it somewhere, and you can replace or upgrade the payload when you need. So all the concept of redundancy and reliability that has been a nightmare for the space industry for many years, it becomes completely different, and it turns to an MTBF problem. I mean, you need to identify how long it's going to take till you need to make your MTBF compatible with your servicing time in this platform. So I think these are opening new doors. to provide these new connectivity services in a very affordable manner. At the end of the day, I think there is a great market out there, and the question is to be able to address that market with an affordable capacity.
James, I know you're an imagery company, but you're operating all kinds of satellites now, like from very small CubeSats to larger platforms. Where's that going? What's the direction? Are you going smaller? Is it going bigger?
So that's a really good question, because I mean, there's as a new space company, we see it's not just about resolution, it's about also temporal. So we talk about real time, we talk about daily change, and that's been a key driver, a differentiator around Planet, is the ability to capture change every day. So we're imaging the whole Earth, which is like 150 million square kilometers a day. And all of that also creates a big data problem. So, the three key things are temporal. We're also seeing a lot of demand for spectral. So looking at different bands in not just what you can see.
Get the data down.
In terms of actually the images themselves, so the ability to actually be able to look at it from things like near infrared and all of those different
bands, not RF bands.
Which is really important, because if we move into analytics, computers can do things that we can't do as humans, and so being able to differentiate between spectral bands is really important. So we're innovating in all three ways. We're innovating in temporal, spatial in terms of resolution, but also in spectral, the bands. The other thing that's really important is, because we're capturing all of this data, it's the ability to make it accessible. So there's no good having it if you can't get it. So we're using cloud, big infrastructures. We've got 34 ground stations. We've got massive infrastructure. We've got 22,000 virtual machines that process this stuff automatically.
22,000.
Yeah. So the virtual network that we use, which is actually based on Google Cloud, and is actually processing all this information. So it's there isn't the human intervention that we used to. So it's all automated, which means that from capturing an image in space, like you see on the picture now, we can have that in the hands of a customer within sort of hours, and ultimately getting to Hervé's idea of being able to see change and therefore getting to near real time.
Hervé, are you guys using the cloud as well for this mapping and data?
Yes, yeah, we do also use cloud. So. Well, in various areas. So indeed, the amount of data that we are manipulating is best to be handled in the cloud. So we do have our mapping solution and hosted also there. So everything comes there and is basically processed. So we also expect to deliver from the cloud to the end user in an incremental way. So all this would create a virtual circle, basically from the customer, feeding sensor feedback to the cloud, and then processed in the cloud, and then back from the cloud to the end user. So that's what we are currently working on.
Now, do you view Google and Google Maps and Waze as competitors, or how does that work?
Obviously, yeah, they are in the same area. So we are a handful of companies which are able to cover the full globe. So yes, they are one of our competitors, and we need to stay alert in this industry. Of course, this requires a lot of investments. And well, at TomTom, we try to, because of our size, to select our battles. And today, in order to tackle the real-time aspect, so we invest on technology, and one of them is artificial intelligence, because we want to indeed utilize this in order to speed up and to avoid all the manual touches on the map updates. So not so long ago, map updates meant thousands of people digitizing all sorts of source material. So now what we're trying to do is to automate, but still keeping in mind the quality. So quality is still very much important, because especially if we think about autonomous driving, there you wouldn't expect an error in your map while you drive autonomously, obviously. So so quality is important, and therefore we need to find the new algorithms which will combine automation as well as quality checking at the same time. And there I think artificial intelligence can really help. So we are investing a lot in indeed analyzing pixels and extracting information out of it. So we do all sort of things like extracting water bodies, land use, roads, lanes, all sort of paints on the ground that we can identify. And all this is then integrated and augmented with all sort of other sources in order to create a final product.
Does it make sense, maybe Alison, you can help me with this, does it make sense to put the cloud in space to actually store and manage data up in space, or do we just do that on the ground?
So
it's one of the questions from the audience. So,
to be honest, there's been talk of how much easier it would be to cool a data center if you stick it on the moon. Whether or not we'll ever do that, I think we've got to get back there in person first before we start building data centers. For now, we've got the Arctic. I mean, our GPUs are all over anyway. They're in the cloud, and if you take automotive, for instance, it is phenomenal how much data comes from one single car, and that includes the fact that you then have to put that with your localization data, so where things are around you, situational data, the mapping itself, where you are geographically, and you combine all that. We cannot possibly comprehend it. I mean, we do a fairly good job right now with our own brain in driving, but when you actually look at the stats of how many people are killed on roads, we have to start doing better. We really do. And AI will help simply because it has absolutely no problem taking millions and millions of different parameters, different types of data and different vectors, converting it into maths, doing the matrix multiplication on GPU and figuring out the actual problem itself on a grand scale. If you then take that into space, it's a similar kind of thing. For example, James was talking about using channels. One of the teams that were working with Sentinel data were literally able to use, for various reasons, they only use 10 of the 13 channels, the varying frequencies of the spectral data that's coming in. They were able to use that, and literally it turns out that tin, which you can see from this data, from this spectral data, through the massive amount of data globally that is coming in on satellite, it turns out that's a really great proxy for informal settlements, because tin roofs and slums, and that's just one tiny little example of what you can do. But there is a host, the United Nations Sustainability Goals. There's a host of different applications, and this satellite data can solve the majority of them. It really can, but we need to figure out how. And our little human brains aren't capable of doing it on our own. We need big compute and artificial intelligence.
Let me riff on that for a second. So we are our own computers, right? We have our own brains here, but you're suggesting in some ways that the actual artificial intelligence computers themselves would be better or maybe able to make decisions that we can't even comprehend or think about. So for a self-driving car, they'll be safer than we would on the road, right? They would have, taking all that data in, they'd be able to make decisions maybe even faster than we would as humans?
It's really, really important to state loud and clear that this is about augmenting us with AI. So most of today's AI is very narrow. We are very, very far away from what we call AGI, human level AI. But up until that point, it is always going to be humans augmented by AI. So our decision making helped along by the massive parallel processing capability of artificially intelligent systems, no matter what the problem is that you're actually trying to solve. So that's really important. But on a safety side, there is a lot that's being done. And actually for quite a few years, we've had things like, for example, attention models, where you can literally see and you can provide imagery of where the neural network has been focusing to get that particular decision. That's years old research, and we're getting closer and closer. There is a huge body of research going on right now purely on safety and the ethics and the morals of using AI. But the simple fact is we were not built to, take the human genome, for instance. There is no way that we can contemplate the huge amount of data in things like genomics. and on a global scale, all of the data coming in from all of the satellites. There's no way. So we need help.
Very good. Fascinating. Let me stick on cars and for a minute. We can't run fiber to cars, right? We're going to need to interconnect cars by satellite or terrestrial means. The mapping piece of this, what do you think? Are we going to, how far are we away from all these automated self-driving? The car will just show up at my house, no driver. It'll be connected to the web and to all these databases. It'll be making real-time decision making. Is that 2 years away? What do you think? 3 years away?
Well, that's a difficult guess, to be honest, because technology is there. We see it working right in the streets. There are many test bench, in the US, large-scale tests are being put in place, but until it gets on the roads massively, I think we still have time, because we need a lot of policy making behind it, and certification, making sure that we have definite proof that it won't do anything stupid, and so on. So I think, and for this I will not give a bet, so I will not tell you anything. What I know is that it will still take a bit of time.
You guys have an opinion on the car piece?
Yeah, I think it takes time. I mean, there are two things we need to take into account: how the technology evolves and how the society is able to digest that technology. So I think the technology probably is there, or is almost there. It's 90% there, but now it takes the time for the human being, for the society, to understand, to accept that technology, and to integrate that technology in our daily lives. And this is mostly related to legal and insurance aspects. I think that those will be the key aspects that will determine when this autonomous car will become massive.
Any opinion?
Yeah, I think there's another challenge to this in terms of in an autonomous car, it's taking multiple feeds of information from multiple sources. So provenance of information is important. So if putting it together and making sure it's correct and accurate, where's it come from? Because you're relying on that as a human being, you're going to be relying on those decisions. So you want to be sure in the design and everything else that provenance is a key as well. Because if the information is not correct, bad decisions, then you get into health and safety issues. So I think the whole data provenance and data governance is a really important aspect, as well as the legal frameworks.
So, Alison, collaborating across all these different types of platforms, integrating all this kinds of data, how does that work? How do you guys see, from NVIDIA's standpoint, how are you going to pull all this together? How did you work to do that? Is it just coming from different streams and you put it together, or do you actually go out and actively look to build partnerships there?
It is all converging. It seems to be. If you take collaboration, take collective intelligence, we've finally figured out that if you get a good group of people together, then you get a really broad overview. You get wide understanding. If you then put that into, let's say, robotics, whether that's in automotive. So, for example, if we could jump straight to fully connected cars, we wouldn't have a problem at all. Because the cars will be able to already predict potential accidents and make adjustments. And the fact is that we have to and this will take some time, integrate humans into the collective, autonomy of driving. But then think of that in the space domain. If you had collective intelligence in a constellation of satellites, if you had collective intelligence in an exploratory train of CubeSats. Think of the cost alone, how small that cost is compared to building a huge spacecraft, to go to one of the planets, for example, when you could actually have collective intelligence from a train of small CubeSats. And this has been developed and has been for a long time. It's called swarm robotics. You can also do a lot of development in a simulated environment at no cost as well. And a lot of the development that's going on in cars, as I said, this is driving AI, but also it sounds like it's also driving the space industry and intelligence in the space industry. Simulation has infinite possibilities at zero cost. This is a virtual environment. You can factor in any corner case. You can come up with any corner case. And this is the stuff that we don't think about, and the reason that we still have accidents in cars on the roads today. So it is converging, and NVIDIA is working on every single aspect of that. We have a fleet of our own cars. We've built the hardware. We've built the massive supercomputer infrastructure. We've now got over 1,000 nodes, and by node I mean an 8 GPU server. And this is what we need to actually handle the data coming in from the cars, but also our own internal research. You know, we do a staggering amount, but we also have to enable everybody else. And we work with so many other people that we have to enable them. So it's not just the hardware, it's the software as well. And it is unprecedented how fast software is moving. You know, I joined NVIDIA 3.5 years ago, and we were just talking about single GPU. You know, we're now talking about pods of servers, and we're writing white papers, you know, every couple of weeks for customers to reference how you do that and all the best practices of it. So you have to factor that in behind it. I spoke about this yesterday. If you think that embedded, so what we call Jetson, you know, the credit card sized GPUs, is 5% of the job. 95% of the job is analyzing it, and you need good compute. AI requires compute. So it is, you know, every single facet of it for NVIDIA.
We had a question from the audience about latency. So I'm curious about latency, maybe not so much on the Earth observation side, but on the connectivity side. How does latency come into play with this? Both, well, for a typical geo satellite, you're going up a half second, right, and down. But on the ground, if we're talking about cars or computers making real-time decisions, latency has got to, not only in this, but in gaming, obviously you're in the gaming side, but latency's got to play a role.
Yeah, latency is key for these real-time systems, and we recognize that. And this is why we see the opportunity for these LEO constellations or the high-altitude platforms that will play a very important role, because they can have latency values like at the level of the fiber, or even better than the fiber in the case of the hubs. So with these high altitude platforms, we should be able to connect cars, and with a very low latency that would be better than the fiber. So this is definitely key, and we have a solution for that.
Hervé, when we're talking about real time, do you have a yeah.
Well, yeah, obviously latency in the autonomous car industry will be quite key. But I think also what we shouldn't forget is that an autonomous car is going to be a system which is going to be made of redundant components. So we have, well, whenever one will be failing, so if the latency is not there, for instance, we expect the other system to take on the job as well. So it's not just one channel that will be important, and this one is certainly very important to get the full fledge of the services. But we also expect the other system to take over if there is one that fails. So it's not just one answer.
James, on your side, maybe not latency, but what about the refresh rate of this data that's coming down from your spacecraft? How does that work?
I think that again, you know, we're all driving to make things near real time. So you know, you asked Hervé about Google Maps earlier. You know, Google Maps can be sort of 6, 9, 12 months out of date. You know,
right. Yeah, I go look at my house and it's yeah, totally different.
So you know, for us in Earth observation, you know, latency is an important factor, but freshness is as well. So moving to this concept of being able to monitor change daily, that means we're able to actually capture change on a daily basis. So we're no longer having to, the traditional Earth observation is taking snapshot, tasking an image, getting that image, and then tasking again. Now we're into the process, because we have it everywhere and it's always on, we're able to capture images every day. So we can see change happen on a daily basis.
And monetize, if you can see that change.
And we can see the change.
How do you monetize that, that data?
You know, it goes back to what Alison was saying. You know, the user cases with the advancement in technology and the ability to understand change and the freshness of that, suddenly that opens up things that we couldn't do before. So there's two aspects to that. One is the fact that the volumes of data are huge. So you need to be able to analyze that. And with us, we're using AI now to actually do machine learning through using neural network technology and techniques. But it's training and the educating on the algorithms that's really important, and having deep stacks of imagery for us gives us that unique perspective that we can train it to look through all this data and say, right, that's a car, that's a road, that's a building. So that's key. The second thing is, as change occurs, you want it to be automated. You don't want to have to look as a human. You can't look across the whole world. And if you're wanting to know, how the crops have changed in the last week, what's been the impact of weather change and climate. I mean, we see that climate change having a massive impact on the whole world today. Having that ability to be able to know where to look, being able to monitor. So we have this concept of using satellites to monitor and identify change, and therefore do that on a basis that can then feed that information into whatever source. So we're coming across loads of new user cases now.
Fantastic. Allison, killer robots? Are we in danger? Are we at risk? This artificial intelligence thing. Should I be awake at night?
I'll just bring up my robot that has the planned answer already because I just wanted to say, by the way, the number is 7 milliseconds. That's what
7
people
milliseconds.
kind of work on for the latency at the moment. But it's constantly evolving. AI is constantly evolving, and we haven't yet determined what the acceptable number would be. But if you are slower than 7 milliseconds, then try again. That's basically what we're doing at the moment for especially for automotive. Killer robots. As I said, we're really, really good at data-dependent artificial intelligence. Most of the systems that you see today are using something called supervised learning. And they are trained on labeled data. So this is data sets that we've created. The teams that were working for over the summer with ESA and Sentinel data, for example, we're using data sets that thankfully were geotagged by UNICEF, and because they've been working on the ground for so many years, they have all this kind of data. Supervised learning is entirely dependent on that data set. So think of it as experience that we would gain as humans. This is the experience that you give the AI system to then go out into the real world and make a prediction based, in real time, or at latencies of no more than 7 milliseconds. Make a prediction and act on it. Now, killer robots. They would only be killer robots if we programmed them and gave them the objective to kill. I don't want to get into the whole autonomous weapons debate.
Let's be nice to the programmers then, right? We want the programmers to program killer robots for us.
Well, it really depends. With supervised learning, you are basically teaching a system how to do something dependent on the data. There is something called reinforcement learning. This is far more powerful, and it's a lot closer to how we actually work as humans. And that's basically give the AI agent, whether that's a physical robot or a virtual robot. At some point in these pictures, there's a cute kind of nursery-looking image, and that's one of our virtual robots. Give it an objective and let it, by extreme trial and error, figure out how to get to the optimal solution, or how to maximize return, how to maximize its rewards, essentially. So if you've given a reinforcement learning agent the objective to kill, a certain thing, then it will do it. It's as simple as that. The big question for society right now, and the ethics and the morality of AI, is how do we set an objective that could be as simple and pure as have that satellite, go to A without having any kind of bad repercussions in getting to that optimal position. Or it's kind of like I don't know if you've heard the paperclip story, but basically you set a system to make as many paperclips as possible, make lots of profit, and in the end it realizes that humans are just using all the resources, so they don't need them, and you get rid of the humans, and then you can just make endless amounts of paperclips and versions of that. It's about setting the objective. Killer robots, honestly, I love the movies, they're great, they're great entertainment. But we're also nowhere near that kind of level, human level intelligence, or what we call artificial general intelligence. Just think, from the robotics point of view, how difficult it is to program a robot just to pick up that glass and tip that water into, my mouth. It's really, really hard. So.
And not break the glass, right? And or
Yeah,
spill the water.
not break the. I mean, actually, gripping is kind of a done thing now. But just there's no way that robots, even Sophia, if you've heard of Sophia, so this is Hanson Robotics robot, cognitive robot, is only capable of having to an extent, a conversation halfway towards how in depth it is here, if you've provided a lot of the information beforehand.
Okay, very good. I think we're almost out of time. I got one more question for each of you. Okay. Favorite science fiction movie and why? James?
2001: Space Odyssey.
Excellent choice. Excellent. I can't disagree.
It set the bar. It defined AI. It started to introduce it.
Hal? Antonio?
I'm afraid we'll be on the same page, but just to change, let me recall also Solaris. That was an interesting movie, also science fiction. Good. One of the greats.
Hervé, do you have a choice?
Well, the Star Wars trilogy and the old ones.
Not the Terminator, I take it?
No? Absolutely, definitely Contact. So when I set up when I helped set up Frontier Development Lab, SETI is the bridge between NASA because they can't work directly with private enterprise. So the whole endeavour revolves around the SETI Institute. And Contact was a film that SETI's Jill Tarter. It was about Jill Tarter, although it was dedicated to Carl Sagan. And Jodie Foster plays the scientist in the film, and she actually spent a lot of time with Jill Tarter because it was pretty much based around her to learn how to, be in that kind of environment. And we, in the first year, all of the fellows from the first year of Frontier Development literally sat down in SETI and watched Contact with Jill, and it was like, one of the big highlights. So Contact, it's a great film. If you haven't seen it, go.
Thank you. Well, thank you guys. Thank you for joining us. Thank you for this fascinating discussion. Please join me in thanking our panelists this morning.
Thank you.
Well done.